This last example will use Bayes' theorem as well as tree diagrams to help you calculate probabilities. So in this example, there is a viral outbreak on the planet Caprica, and it has infected 17% of inhabitants. If infected, there is a 99% probability a patient will test positive. If not infected, there's only a 2% chance that the patient will test positive. So the first question is, what is the probability a randomly selected Caprican will be infected and test positive? So in order to complete this problem, I'm going to use a tree diagram because I find that helpful in these situations where we have these sequential events. So we have individuals getting infected, and then after they're infected, they are tested. So the first thing I'm told is 17% of the inhabitants are infected. So I know that, and let me maybe use like I for infected. So the event that the individual is infected, I'll use I. And then maybe I'll use P for if the individual is positive. So what I know is that 17% are infected. And so that leaves me with a complement of 83% are not infected. Second, I'm told that if they are infected, there's a 99% chance they will test positive. So there's a 99% chance of testing positive, and that means that there's a 1% chance they will not test positive. I'm also told that of the people who are not infected, 2% will test positive. So I have 2% here testing positive, which means that 98% will not test positive. Okay, so that just helps me to organize the information I was given, that's all. Okay, so the question asks me, what is the probability a randomly selected Caprican will be infected and test positive? Okay, so right here I'm thinking of the multiplication rule. And this, using the multiplication rule, I know that the general multiplication rule tells me that this is equal to the probability that the person is infected times the probability that the person tests positive, given that the individual is infected. So the probability, so this is, as I said, the general multiplication rule. So the probability that an individual is infected is, we know, is 0.17. And the probability that an individual tests positive, given that they're infected, is this conditional probability right here. So we are basically, so the probability we're seeking is basically just the probability that goes along this branch right here. And that probability is 0.1683. And I'm not going to bother rounding that. So that's about 16.83%. So we would also like to take a look at the question B. And that is, what is the probability a randomly selected Caprican will test positive? So if we look at the tree diagram, we can see that in this case, the Caprican tests positive, and also over here in this case, the Caprican tests positive. So we will be using the total probability formula. So the probability of a positive test is going to be equal to the probability that an individual is infected and tests positive. So that's this branch right here. plus the probability that an individual is not infected but tests positive. So not infected but test positive. So here we're going to use the general multiplication rule. So we know that this will be the probability, this guy will be the probability of being infected times the probability of testing positive given that one is infected, plus this probability can be calculated as the probability an individual is not infected times the probability of testing positive given that the individual is not infected. Okay, and so I'm just going to calculate these probabilities using the tree. So this probability here is just 0.17, and this probability here is just my conditional probability. And then this probability here, the probability of not being infected is right here. And the probability of testing positive when you're not infected is right here. So we have 0.83 times 0.02. So the probability of testing positive is about 0.1849 or about 18.49%. Okay, the last question that we want to answer is part C, and that is, what is the probability of being infected given that one tests positive? Okay, so this is a conditional probability. Another way we could write this is find the probability of being infected given that the individual tested positive. So this is a conditional probability, and we do have a formula for this, and it's the probability that one is infected given that this individual tested positive. That's the probability of being infected and testing positive divided by the probability of testing positive. And this is the conditional probability formula. For us, this really corresponds to, recall we already calculated this probability in part A. It was just the product of these two probabilities. And recall also we calculated this probability in part B. And that was the sum of this probability and this probability. So I'm just going to use those answers that we already calculated. For part A, the probability was 0.1683, and for part B, the sum of those two probabilities was 0.1849. If I divide, I get 0.910221. I'm going to round that to 3 decimal places. So there's a 91% chance that you are infected with this new virus if you test positive. This also is Bayes' theorem. I just want to point out, in order to find this probability, the probability of being infected, given that you tested positive, this is an application of what we call Bayes' theorem.